All right. So the first piece of this is imaginary numbers, and imaginary numbers are the numbers that get outside of real numbers. So we get imaginary numbers when we have negatives under radicals. So here, if we were going to reduce this square root of negative 90, keep in mind that an imaginary number I is the square root of negative 1. So I'm going to break this 90 down into negative 90, into negative 1, and then I'm going to ask myself, is there any number that is a perfect square that I can divide out of 90? So any perfect square that divides out of 90, yes, that perfect square is 9. And then what's left over would be 10. So I pick the 9 because it's a perfect square, and then I ask myself, what do I multiply 9 by to get 90? Well, that would be 10. So if negative 90 is negative 1 times 9 times 10, then the square root of negative 90 is the square root of negative 1 times the square root of 9 times the square root of 10. And so we know that the square root of negative 1 is I. We know that the square root of 9 is 3. So we're going to write that as 3I, not I3, because we wouldn't say x3, we would say 3x. And then this rad 10 comes down. So this would be 3I rad 10. Okay. Now when we're adding, subtracting, multiplying, and dividing, we're going to treat I as a variable. We're going to do the same thing that we always do with any other variable. The only thing we need to remember is when we're multiplying, that I squared, since I is the square root of negative 1, that means that I squared is negative 1. Okay. So when I'm adding, I'm just going to combine like terms. So negative 11 plus negative 20 is negative 31. And a negative 8i plus 21i is 13i. And that's it. Now, keep in mind that the calculator will do these for you. I is right here. It's above your period, your decimal point, excuse me. It's above your decimal point. So you could put this in your calculator exactly as you see it here. Negative 11 minus 8i plus negative 20 plus 21i. And you should get the same answer, which we did. So for the next one, I could again combine like terms. Negative 19 minus 8 would be negative 27. 16i minus a negative 8i would be 24i, right? Because minus a negative 8 would become positive 8. Or negative 19 plus 16i minus 8 minus 8i. Okay. And then for multiplication, we'll FOIL. So 2 minus 2i, 10 minus 3i. So that's going to be 20 minus 6i minus 20i plus 6i squared. But we said before that I squared is the same as negative 1. So this would be 6 times negative 1. And that's going to be a negative 6. And now here, a negative 6i and a negative 20i are going to be a negative 26i. So then we're still combining. 20 minus 6 would be 14. And again, it doesn't ever hurt anything to check this. 2 minus 2i, 10 minus 3i.
Hey, Jess, and for more, does it always have to be in A plus BI form?
Yes. Look.
Oh, yeah. All right. Okay.
On legit every single question. Now, just like radicals, you can't have i's in the denominator. So you're going to multiply by, if you have just one term, you're going to multiply by that term. So I'm going to multiply top and bottom here by 3i. So 3i times 4 is 12i. 3i times 3 is 9i squared. And then on the bottom, 3i times 3i again is 9i squared. Keeping in mind that I squared is -1, then this would become 12i plus 9 times -1 over 9 times -1, which would then be -9 plus 12i, because a plus bi, over -9. I don't think that more is going to let you keep that negative in the denominator. So I would change the signs of everything. Now, that's actually, I shouldn't have done that. Pretend I didn't circle that or square it or whatever. 9 minus 12i over 9. That's not a plus bi form. A plus bi form, you'd split this and make it 9 over 9 minus 12i over 9. And so 9 over 9 is 1. And then 12 over 9 reduces to 4/3. And so that's your final answer. And again, just for consistency's sake, let's check this in the calculator. Always remember that when you're doing these, if you have more than one thing going on, put numerator and denominator in their separate parentheses. So really, I should put that in its own parentheses too, otherwise I'm going to get it wrong. Now that's, if you press math enter enter on an a plus bi, it will turn that into a fraction for you. So math enter enter works here also.
Nice.
Okay. And then if you have more than one thing going on in your denominator, then you have to multiply top and bottom by the complex conjugate. The complex conjugate is whatever you have in the denominator with a different sign in the middle. You keep the sign out front, you change this sign. So again, that's called the complex conjugate. It's the same thing that you have in the denominator, just with a different sign in between. And now I would FOIL in the numerator, FOIL in the denominator, combine and reduce. I don't feel like doing all that. 4 plus 137i over. The calculator knows that you're not allowed to have i's in the denominator. So if you give it something with i's in the denominator, it's going to be like, what? No. I mean, it would have taken me a while to do that, and I'm sure that I could have gotten the right answer. But I will tell you that the calculator did that way faster than I could. And I know that Andy did a few of those out for you. So, or at least one. So I'm not doing it. No offense. And then the last thing that I want you to know about I, that again, I'm sure Andy addressed in his video, is that I goes through patterns. So I is the square root of -1 I squared is negative 1. I cubed would be I squared times I, so that would be negative I. I to the 4th would be I squared times I squared, so that would be negative 1 times negative 1, which is 1. Anything past this, I to the 5th would be I to the 4th times I to the 4th is just 1. I to the 6th would be I to the 4th times I to the 2nd. I to the 7th would be I to the 4th times I to the 3rd. I to the 8th would be I to the 4th times I to the 4th. And this pattern is going to go on and on and on and on forever. So if we wanted to know what is I to the 70, well, every multiple of 4, every exponent that's a multiple of 4 is going to be 1. So I know that 66 is a multiple of 4. No, so I was right, 68, sorry. So this would be I to the 68, and then I to the 69, I to the 70. I actually have not tested this in the calculator. I've always just done it that way. So let's see if the calculator does it right. Ooh, what did I do? I bet it does. Hey, look at that. What if I did I to the 71? Yeah. Cool. So the calculator will do those for you also.
Can I see what you did on your calculator really quick?
I just did exactly what it shows right here. I to the 70. See it?
Yeah, but where's I on my calculator?
It's the second and then decimal point. See it right there? Second and then decimal point.
Okay, cool.
All right. So, for 3.2, it starts, I'm pretty sure this is 3.2. It starts with solving quadratics. We have talked about those, so I'm not doing them again. You can go back and rewatch that video. They're all on YouTube. I want to get into the rationals and into the equations with you. So here, I guess this one's quadratics and then the other one is rationals. Yeah. So we're not solving again. You can do that. Here we're going to talk about properties. So the vertex of this quadratic is its turning point. So that's -1, -4. And then that is a minimum. And it is a minimum of -4 that occurs at w equals -1. That's going to be what it wants there. And I know that's w because of that right there. Every quadratic has a domain of all real numbers. Every quadratic all the time always has a domain of all real numbers. There are no restrictions. There's nothing like, you know how with the rationals we're like, oh, you can't have a denominator in the rational, or with the square roots, oh, you can't have a negative under a square root. There's nothing like that going on with quadratics, so their domain is all real numbers. And then the range here, if we're looking from bottom to top, it starts at -4 and goes up. So the range is -4 to infinity. The w-intercepts are right here and right here. So that's going to be -3, 0, and 1, 0. Remember that comma in between them also. The q of w-intercept, that's the y-intercept. So that's going to be at 0, -3. On what interval is q increasing? So that's going to be this half, because this is the half that's going up. So it's increasing from -4 to infinity. And then it's decreasing on this side from -infinity to Nope. It always wants x values. I don't know why I did y values. So it's increasing starting here at -1, and it's decreasing ending here at -1. And then the right-hand x behavior, as x goes up, y goes up. Left-hand end behavior, as x goes down, y goes up.
Can you show the w-intercept of q and the q of w-intercept, how you got that again?
This is the x-intercepts and this is the y-intercepts. So it crosses the x-axis at -3 and 1. And it crosses the y-axis at -3.
Oh, okay.
Okay.
And one more time with the interval increasing and decreasing, why we have the negative ones?
Because you always want the x value.
Just the x value.
Yep.
Both of them.
Yep.
On this particular properties, right?
Yes. So increasing and decreasing, it always wants that x. Where is it increasing and decreasing? Never the y.
Would it be -1 and -3? No.
It's
Would that be two different ones since it's a quadratic?
nope. That should be the x value of your vertex. Whatever the x value is, it should be the same as your x value on your vertex because that's where it changes direction.
I see.
Okay. All right. Now, if we're going to write an equation, I'm going to start with vertex form. The vertex here is 1, 2. So that means that h is 1 and k is 2. Plus 2. And now to figure out what my a is, I'm going to pick any point besides the vertex. So like, how about this point right here, 3, 3. And I'm going to plug those in for x and y. So 3 equals a times 3 minus 1 squared plus 2. And I'm going to solve for a. Subtract the 2. And divide by 4. So then my equation here is k of w equals 1/4 w minus 1 squared plus 2. And you can pick any point, like if I would have done this point instead, or this point instead, or this point instead, I still would have gotten 1/4. Okay. Now, I'm sure that Andy went through a super fancy way to show you how to graph these, but TBH, I'm going to use my calculator. y equals, turn those plots off. And then don't forget to reset your zoom. That's zoom 6. So y equals 4x squared plus 8x plus 3. And then more needs any 2 points, or the vertex and 1 point, I think. So the vertex here is -1, -1. And then it looks like you have another point right here at 0, 3. And you can go to your table. Let's turn that, go to second and then window. And we're going to turn our independent back to auto. And then go back to our table. So any one of these points would work. Your vertex is at -1, -1. And then you could do -2, 3 as your other point. And then that's all you need for more to be able to graph these.
What did you get from the calculator again when you went to table? You just got whichever one from there, whatever
Yeah, any point.
Okay.
I saw on the graph that the vertex was -1, -1. And then I went to the table and got any other point.
Okay.
And that, where you went over, was it window? You said, is that independent on something?
Yeah, so you do second and then window, and that'll get you to table set. And you need to set your independent back to auto.
And you have to know for other things how to turn that on and off when you need it, right?
Yeah.
So yeah, sometimes you can kind of get stuck.
Okay, now if you're given an equation, you can certainly use the minimum function on your calculator to find the vertex. So 2x squared minus 11x minus 21. No. So then if we go second and then trace to get to calc, and we do minimum, I want to see my cursor. There it is. On the left side, on the right side, on the left side, I mean first, and then on the right side second. Where are you? There it is. And then enter again, and then enter. So I got 2.75 negative 36.125. Now you can also do this by hand. First you would find the axis of symmetry, which is negative b over 2a. A, B, C. So that would be a negative 11 over 2 times 2. So that's going to be positive 11 over 4. 11 over 4 is 2.75. So you start here. And then to get your y value, you would plug this into your equation for x, or c in this case. So you would do 2 times 11 over 4 squared minus 11 times 11 over 4. Oops. Minus 21. Ooh, I got something different. What did I do? Oh, that should be a minus. There we go. And then see how I got the same thing that I got when I used the minimum function. And so then if I wanted a fraction, I would just do math enter enter. And it would be 11 over 4 comma negative 289 over 8. But it said 3 decimal places, so the calculator works. If you're more comfortable doing it by hand, then you can do it this way. Okay? So then that means, now since a is greater than 0, that means that this parabola opens upward like this. And if it opens up, then the vertex is a minimum. If a is negative, then the parabola opens down and a is a maximum, and your vertex is a maximum. So this is a minimum of, and then whatever the y value from your vertex is. At k equals, and then whatever the x value from your vertex is. Domain is always all real numbers for a quadratic. The range here always involves the y value of your vertex. And since this parabola opens up, that means that your range is negative 36.125 to positive infinity. Now, if a had been negative and this had opened down, then my range would be negative infinity to, and it would stop at this y value. Now, to find your intercepts, we have to solve this. Does this factor? 2 times 21 is 42. 42 divided by 3. Yes, it does. Okay. So 2c squared minus 11c minus 21. If it doesn't factor, then you have to use the quadratic formula, but that would be annoying. So 2 times negative 21 is negative 42. Two numbers that multiply to negative 42 and add to negative 11 are a negative 14 and a positive 3. And then we group. A 2c squared and a 14c have a 2c in common. A 3c and a 21 have a 3 in common. So then that would be c minus 7, 2c plus, why do I write it out right now? 2c plus 3. And we're going to set those equal to 0. Because remember, the x-intercepts are when y equals 0. And the y-intercepts are when x equals 0. So then this would be c minus 7 equals 0, or 2c plus 3 equals 0, c equals 7, or c equals negative 3/2. So 7, 0, negative 3/2, 0. And so then to find the y-intercept, I set x equal to 0. So y equals 2 times 0 squared minus 11 times 0 minus 21. But that's 0 and that's 0. So my y-intercept is at negative 21. Now again, this is opening up, so the left side is decreasing. And it is decreasing from negative infinity until the x value of my vertex. And the right side is increasing. And that one starts increasing at the x value on my vertex and then keeps increasing forever. And so then end behavior as x goes to infinity, y goes to infinity. As x goes to negative infinity, y also goes to infinity. If your parabola had opened down, then both of these would be negative infinity. Okay. All right. So here we have a NASA rocket launch given an equation. The first thing they want to know is how many seconds will splashdown occur. So splashdown means that the rocket has landed in the ocean, which would mean that its height is 0. So I'm going to set this equation equal to 0. And I'm going to solve for t. So I think the quadratic formula would be the way to go here. That's a negative 4.9. Negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. I'm going to put everything that's under the radical in my calculator at once. 298 squared minus 4 times negative 4.9 times 108. (90920.8). 2 times negative 4.9 is negative 9.8. The square root of 90920.8. 301 point, how many decimal points do they want? 3? 531. (298) plus or minus 301.531 divided by negative 9.8. So let's split it. Negative 298 plus 301.531 over negative 9.8. Negative 298 minus 301.531 over negative 9.8. Okay. Negative 298 plus 301.531 divided by negative 9.8. Can I have a negative time? No. Minus 301.531. Divide that by negative 9.8.
You said, can I have a negative what now?
Time.
One more time.
T stands for
Oh,
time.
negative time. Gotcha. Sorry.
61.177 seconds. You don't need the S. And then how many meters above sea level does the rocket get at its peak? Well, for that, we're going to do the vertex. So anytime they ask you for the maximum or the minimum, you're going to look for the vertex. So we're going to start with my t equals negative b over 2a, just like I said above. So here that would be a negative 298 over 2 times negative 4.9. So negative 298 over negative 9.8. Now that's the time at which it reaches its peak. They asked me for the height. So to figure that out, I take this and I plug it in. Negative 4.9 times 30.408 squared plus 298 times 30.408 plus 108. And obviously, let's do that in the calculator. This answer is second in the negative sign, and that just means whatever the last thing that you found. So that way I don't have to keep on typing 30.408. Laziness. So 4,638, how many decimal points do they want? 3? 4,638.16. And then if it's launched from a launch pad and we want to know how high does it get, well, the launch pad, its launch would be when time is 0. So at the point when it's launched, we haven't started counting time yet. So the launch would happen when time is 0. So then this would be negative 4.9 times 0 squared plus 298 times 0 plus 108. And then this is going to cancel and this is going to cancel. So we would just have the 108. Okay. Last but not least in this section, the table below represents heights of an object thrown off the top of a building. So quadratic regression is done almost the exact same way as linear regression. So we're going to start by, that made it worse. I mean, okay. So we're going to start by going to second and then stat, or not second and stat, just stat. And then pressing enter for edit. And then we're going to put delete, 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 delete. Nope. Oh no, I deleted list 1 and list 2. Okay, so there's a way to get those back because I pressed the wrong button. If I go to stat and then setup editor, I'm pretty sure that does it. Yep. So then we're going to delete the values, not the lists. There we go. Okay, and then in list 1, I'm going to put my t values. So 0.5, 1, 1.5, 2, 2.5, 3. In list 2, I'm going to put my h of t values. Okay. And then just like the other day when we were doing linear regression, you go to Stat and then Calc. So we're going to press this button over one to get to Calc. And now instead of linear regression, this time we want quadratic regression. The next one down because it says find a quadratic regression. Okay. So we're going to go to 5 and then press enter. And then all this is good. List 1, list 2, blah, blah. Okay. So here they gave me A, B, and C. And remember, it's y equals ax squared plus bx plus c. So this is my A, this is my B, and this is my C, which means that my equation would be h of t equals negative 4.9 t squared plus 26.4 t plus 55. Okay. And so then how high will the object be? 2.8 seconds after. So t equals 2.8. So negative 4.9 times 2.8 squared plus 26.4 times 2.8 plus 55. So second and then mode to quit back. Negative 4.9 times 2.8 squared plus 26.4 times 2.8 plus 55, 90.504. And then last but not least for this one, how long will it take for the object to be 5 meters? So that means it has a height of 5 meters. So that would be 5 equals negative 4.9 t squared plus 26.4 t plus 55. I'm going to subtract the 5 from both sides. Because remember, with most quadratics, in order to solve, we need to have 0 on one side. And now I'm going to use the quadratic formula. ABC. Make that a t. I was going to make it an x, but it's not an x, it's a t. So negative 26.4 plus or minus the square root of 26.4 squared minus 4 times negative 4.9 times 50 over okay. So 26.4 squared minus 4 times negative 4.9 times 50. And then we want the square root of that. So that's going to be 40.951. And again, we're going to split. So then this would be negative 26.4 plus 40.951 over negative 9.8. Negative 26.4 minus 40.951 over negative 9.8. So this one is going to be negative 1.485. And then negative 26.4 minus 40.951 divided by negative 9.8. But just like before, can we have a negative time? No. So this is going to be 6.873.
I just think it's really bizarre how you're like good at this. Like you just know. Because my head is spinning. Like I need a drink. I cannot.
Thank you. I don't know. I've always loved math. Like even when I was a kid, I loved math. It was always my favorite subject in school. And it's just always like something that I've been like, this is the way my brain works, you know?
It's like you use it like it just makes sense to you. That's how like my mom and my brother are, and me, like I can write an essay, I can do like all other subjects, but math.
Yeah. Yeah. I mean, I believe that everybody can learn. Like everybody can do, you know, even if you're not the best at math, you could still be an amazing mathematician with the right amount of effort. But everybody also has things that they're inclined toward. You know?
Yeah.
Jess, would you mind putting that back for just a sec?
Yeah, I wouldn't mind.
2 shakes.
You know,
Pretty please.
like
Thank you, ma'am.
it's just always something that I've always been good at. I don't even know. Like I can't tell you why or how.
Well, let me just say I am jealous.
And it's not like I can't write an essay. I was a straight A student in high school. Like I always did really well. I got A's in my English classes in college too. It just takes me, I have to put in more effort to write a good essay than I do to do a math problem, you know?
Right.
So,
Oh, thank you, ma'am.
that's what it is. Okay. So then, did I print the right one?
Looks right to me.
Yeah, okay. I thought this was rationals, but I guess rationals are next, and this is the beginning of polynomials. Okay, so the degree in standard form is always your biggest exponent. And then the leading coefficient is always the term in front of the thing that has the biggest exponent. With polynomials, there are 4 different kinds of end behavior. If you have an odd degree with a positive leading coefficient, then your end behavior looks like that. If you have odd negative, then your end behavior looks like this. If you have even positive, then your end behavior looks like this. If you have even negative, then your end behavior looks like that.
Hey, Jessica,
Yeah.
I think the degree for this one's
Oh
next
shit, I
for
didn't even
9.
see the 9 there. Thank you, Alexander. At least one of us is paying attention. Man, we made it all the way like halfway through June. This is like our 8th meeting and 6th meeting, and that's the first time that he's had to correct me. I'm pretty proud of myself. It's not that I
don't know.
mistakes, it's that I fixed them before he had to step in.
Katie got you a couple times last week. Not to bring any old stuff up again,
That's
but
good. Okay, so then here we have an odd degree with a negative leading coefficient. So that's going to be this end behavior. So on the right side, as x goes to infinity, y goes to negative infinity.
What does that say? Odd plus
Odd and
C.
then leading coefficient, LC.
LC.
And then my left hand is that as x goes to negative infinity, y goes to positive infinity.
And then what's the one over on the right? Odd.
Even negative. This is odd positive, odd negative, even positive, even negative. I am 1,000,000% sure he did that in his video.
I told you I was a little bit behind because I
Oh, that's
wanted
right.
to do my review and my test first.
So then the
Oh.
maximum number of zeros we can have is the same as the degree. And the maximum number of turning points we can have is one fewer than the degree.
For the end behavior, you're going based off of whichever number we use the degree or the leading, whatever the leading coefficient is, right?
Both of these things. It's is this even or odd? Is this positive or negative? So you need to know both of those things to know the end behavior. Okay. Now for this next one, the least possible degree, it has 1, 2, 3 turning points, which means that its degree has to be bigger than 3, not 3, bigger than 3. So the least possible degree is 4. It could be 8, it could be 12, but it can't be 2. And it can't be 3.
Ouch.
So since it says least possible, the least possible is 4. Okay. So k is a polynomial of degree 3. Multiplicity 2 at u equals 5 means that I have a factor at u minus 5. And multiplicity 2 means that factor is squared. And if k of negative 3 equals 0, then that means I have the point negative 3, 0. So that is another 0. So then that's going to be u plus 3. Right? Because if I say u plus 3 equals 0, then u equals negative 3. And now the only other thing I need to know is my leading coefficient. So we're going to do the same thing that we did before with the quadratics, and we're going to use this other point that they gave me to figure out what my a value is. So here, when I plug in 0, I should get negative 48. So negative 48 equals a times 0 minus 5 squared times 0 plus 3. A times 25 times 3. Right? Negative 5 squared is 25. So negative 48 equals 75a. Negative 48 over 75. Over 75. Math, enter, enter. 16 over 25. So then my final equation is k of u equals negative 16 over 25 times u minus 5 squared times u plus 3. And they're always going to give you that third point or that other point so that you can figure out what your a value is. It won't always be that this is 0. Sometimes it'll be like k of 7 equals 23, but then you're still just going to plug in your y value here and your x value here. Okay. All All right. Now, in his video, Andy should have told you about types of roots. We have 3 types. We have one that crosses straight, one that bounces, and one that curves. So here we have r equals -2, r equals 1, and r equals 4. That means that we have zeros at r plus 2. Since r equals -2 crosses straight, the degree on that factor is 1. R equals 1 means that we have a factor at r minus 1. And since that bounces at r equals 1, I have a degree of 2. And then with r equals 4 as my last zero, that means I have r minus 4 as a factor. And since it curves at r equals 4, that means that r minus 4 has a degree of 3. Now we still need to figure out our a value. So you're going to pick any point on this graph that you want. You could pick any point that's not a 0, by the way. So any other point. So you could pick this point. You could pick this point.
They're making dinner, trying to figure out what to do for dinner.
In my opinion, if you have a y-intercept that is easy to find, that would be the one to use. So here we have the point 0, 2. So when I plug in 0, I should get 2. So 0 equals a times, no, 2 equals a times 0 plus 2, 0 minus 1 squared, and 0 minus 4 to the third. A times 2 times 1 times -64 2 times 1 times -64 is -128. So a equals -2 over 128, which would be -1 over 64. So then my final equation would be r, what is that? G of r equals -1 over 64, r plus 2, r minus 1 squared, r minus 4 to the third. Okay. Now, in factored form, to find the degree, you add the degrees of the factors. So when there's no degree, the degree is 1. So here we would do 1 plus 4 plus 3. So the degree of this is 8. I'm going to check this one real fast. Because I know what I would want for the leading coefficient, but I want to make sure that I'm telling you the right thing. 3, 4. Here we go. Oh man, I picked a hard one. What the heck? Oh, here we go. Okay, so to figure out the leading coefficient here, we have a little bit of work to do. Because the leading coefficient is the number that would be in front when this was all multiplied out. So we need to look at the terms with t's and their exponents. So I'm not concerned with any of the coefficients here, or any of the constants here, excuse me. Here, this would be 4t. This would be a negative 2t to the fourth. And this would be 2t to the third. And then times this number in front. So if I were trying to get my leading term, just the number in front, those are the pieces I would need. And obviously, if I multiplied this whole thing together, it would be a really long polynomial. I'm not concerned with all of the terms. I'm only concerned with the leading term. So to find the leading term, I just take each term with the variable in each factor and the exponent on that factor. So here, I'm going to do 4 times negative 2 to the fourth times 2 to the third times negative 0.031. And that is my leading coefficient. Because my leading term would be negative 15.872 t to the 1, 2, 3, 4, 5, 6, 7, 8. And now that I have my whole leading term, this is even degree with a negative leading coefficient. So that means my end behavior would look like that. Down on the left, down on the right. So as x goes to infinity on the right side, y goes to negative infinity. And as x goes to negative infinity, why did I write an 8? On the left side, y also goes to negative infinity. Now to find the t-intercepts, you take each factor and you set it equal to 0 and solve. So negative 7 plus 4t equals 0. So 4t equals 7 and t equals 7/4. Oh, they want 3 decimal places. 7/4, 1.75. Then we do the next one. Negative 9 minus 2t equals 0. Negative 2t equals 9. T equals negative 9 over 2. That's going to be negative 4.5. And then my last one, 2t minus 9 equals 0. 2t equals 9. T equals a positive 9/2. Ooh, you can't see that. There we go. So again, to find the intercepts, you set each factor equal to 0 and solve. To find the t-intercepts, to find the h-intercept, you make t 0. 0.031 times negative 7 plus 4 times 0 minus 9 minus 2 times 0 to the fourth. 2 times 0 minus 9 to the third. And that's not something I'm going to do by hand. Negative 7 plus 4 times 0 -9 minus 2 times 0 to the fourth. 2 times 0 minus 9 to the third. Oof. So that's my h of t intercept. Okay. Moving on. Again, to find the degree here, we add the exponents. So 76, if there is no degree, the degree is 1. 97. So the degree is 174. When you have nothing funky going on inside in front of your t's, that would just be ones, right? 1 to the 76 is 1. 1 to the 1 is 1. 1 to the 97 is 1. So just this number out front is your leading coefficient. And so then even with a negative leading coefficient, again, means down and down. So as x goes to infinity, y goes to negative infinity on the right. And as x goes to negative infinity, y goes to negative infinity on the left. Okay. At -8, your graph would, the right answer here is bounce, because the multiplicity is even. At -6, it would cross straight because the multiplicity is 1. And at 9, it would curve because the multiplicity is, I'm going to look at the, I want to get you the exact right wording. Here we go. Yeah, odd greater than 1. Okay. All right, so here, degree is the biggest exponent, so that's a 3. Leading coefficient is then 9, because it's the number in front of that term. So that means we have odd degree with a positive leading coefficient, which means that my end behavior is down on the left, up on the right. That means as x goes to positive infinity, y also goes to positive infinity. And as x goes to negative infinity on the left, y also goes to negative infinity. Now, I didn't play around with this one, but I think it factors. 9r cubed minus 6r squared minus 81r plus 54. A 9r cubed and a 6r have a 3r squared in common. That would leave me 3r minus 2. 81 and 54 have 27 in common. I think 81 divided by 27. Yep. So I'm going to do a negative 27 because if this is negative, then this should be negative also. And that would leave me 3r minus 2 because 54 divided by negative 27 is a negative 2. So this one does factor. So 3r minus 2. 3r squared minus 27. Oh, there was a GCF that I could have taken out at the beginning. These have a GCF of 3. This is the difference of perfect squares. And so then we'd set each factor equal to 0 and solve. So that's 2/3, 3, and negative 3. So 0.6670, 30, negative 30. And I'm pretty sure that the one that you have will be able to factor by grouping. I think that's like the way the question is formatted. Don't forget to look for a GCF first. You'll save yourself some time. I didn't, because I don't know, I forgot. And then remember the h of our intercept, you're going to set r equal to 0. So that would be negative 6 times 0 squared minus 81 times 0 plus 54 plus 9 times 0 cubed. But 0, 0, 0. And then that's it. Which is good because that was a lot.
I'm not really that great at the grouping thing. I know it seems like pretty simple, but then when I get like a different problem and try to do it myself, it doesn't really make sense. What's the other way of doing it outside of grouping?
There isn't another way for this one.
Okay.
Sorry. I just lied to you. There is another way, but we're going to go over it on Tuesday.
Okay.
Because for right now, I need you to figure out how to factor by grouping.
All right.
Okay. All right, so I'm gonna end the meeting. That way my video can process, and then you guys can jump back in, and I will be back as soon as I can. Okay. See you guys in a few minutes.